Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to triple product. So in the previous videos we have discussed about scalar triple product. Okay, so as we know, triple product is of two types. So we have discussed scalar triple product. So now we will discuss about another type of triple product, which is called as vector triple product. Okay, vector triple product. So here in vector triple product, again we have, let's say, three vectors: a vector, b vector and c vector. So this vector triple product, it is expressed as a vector cross b vector cross c vector in this way. So this can be written as b vector, which is again, it is multiplied with a scalar which the value of which comes from the dot product of a vector dot c vector. Dot product or scalar product, it produces a scalar value, a numerical value, so that gets multiplied as a constant value with b vector, minus c vector, that gets multiplied with the scalar value or numerical value resulting from the dot product of a vector cross b vector. So you can remember it as the BAC minus CAB, this rule. By this you can also remember it: BAC CAB, B vector multiplied with the dot product of a vector dot c vector, and minus c vector multiplied with the dot product of a vector dot b vector. Okay, dot product produces a numerical value that gets multiplied as a constant value, and a constant value gets multiplied with a vector, that results. So this expression, it is called as vector triple product. Okay, so we'll solve some numerical problems to understand how this thing works. Okay, so here is a question on vector triple product. So basically we have to prove the whole vector triple product, LHS and RHS. So it is given that we have to show a vector cross b vector cross c vector is equal to b vector multiplied with the dot product of a vector and c vector minus c vector multiplied with the dot product of a vector and b vector. The BAC CAB rule we have to verify. Okay, so let us do that. So first what we have to do is we have to identify, prove LHS and RHS. For that, first we have to calculate the LHS side. The LHS side, which is a vector cross b vector cross c vector. So first we'll determine b vector cross c vector. So that is equal to, we'll do it using the whole cross product method: I cap, j cap, k cap. Then we have the components x, y and z. B vector is 3, I cap, 2, j cap and k cap. 3, 2, 1. And here we have 2 I cap plus 3 j cap plus k cap with 2, 3, 1. Okay. So we'll calculate, that is equal to I cap to 2 minus 3, okay, minus j cap 3 minus 2 plus k cap into 9 minus 4. So that is equal to minus I cap minus j cap plus 5k cap. That is equal to B vector cross C vector. Okay, then we will determine A vector cross B vector cross C vector. Okay, A vector cross B vector cross C vector. So for that, again, component wise, I cap, j cap, k cap. First we'll bring the A vector, the x, y and z components of A vector. So that is 1, 2, 3, and then B vector cross C vector whole. Okay, B vector cross C vector whole, which we calculated here. So it will be minus 1, minus 1 and 5, minus I cap minus j cap plus 5 k cap. So that is equal to, it is coming I cap into 2 into 5, 10 minus 3, which is 10 plus 3, okay, and minus j cap into 1 into 5, 5 minus plus 3, so 5 plus 3, then plus k cap into 1 into minus 1 minus 2, so it is minus 1 plus 2, minus 1 plus 2. So this is equal to 13 I cap minus 8 j cap plus k cap. This is, we have calculated A vector cross B vector cross C vector. This is LHS. This is LHS. Now we have to prove, we will see whether it is also equal to the RHS if we do it this way, that is the BAC CAB thing. So for that, first we'll calculate, the dot product of A vector and C vector. So we will just multiply the product of the respective x, y and z components. So it will be 1 into 2 plus 2 into 3 plus 3 into 1. Okay, that is A vector dot C vector, which is equal to 2 plus 6 plus 3, which is equal to how much? 11. Then A vector dot B vector. A vector dot B vector, again we'll just multiply the respective x, y and z components with each other. So A vector is 1, 2, 3, B vector is 3, 2, 1. So 1 into 3 plus 2 into 2 plus 3 into 1. So that is equal to 3 plus 4 plus 3, which is equal to 10. So we have got A vector dot C vector, that is 11, A vector dot B vector, that is 10. Now BAC CAB. So we'll do the whole BAC CAB thing. So it becomes B vector into A vector dot C vector minus C vector to A vector dot B vector, that is equal to 11 multiplied with B vector, which is equal to 3 I cap plus 2 j cap plus k cap, then minus A vector dot B vector, that is equal to 10, so it is a scalar value. We'll multiply it with C vector, which is equal to 2 I cap plus 3j cap plus k cap. Okay, so this becomes 33 I cap plus 22 j cap plus 11 k cap minus 20 I cap plus 30 j cap, yes, 30 j cap plus 10 k cap. So that is equal to 33 minus 20, that is 13 I cap plus 22 minus 30, which is minus 8 j cap plus 11 minus 10 plus k cap. This is what? This is the RHS. So now let us compare whether LHS is equal to RHS. This is the RHS, 13 I cap minus 8 j cap plus k cap. So here it is 13 I cap minus 8 j cap plus k cap. So either way we are getting the same result. So it means this vector triple product identity, the BAC-CAB rule, it is correct. Okay, we have proved it.